Hello, everybody. Thank you for joining us today for a discussion on technologies for landfill, RNG, and compost monitoring. We're excited to hear from two of our experts today, Melissa Russo and Phil Carrillo, on how technologies are affecting our industry now and their predictions for the future. So as Diane said, I'm Dave Hostetter. I'm a vice president and one of our business managers for our remote monitoring and controls group here at SCS. I'm a professional engineer in Pennsylvania and Virginia. And I've been with SCS for about 12 years, doing work on landfill gas systems and RMC systems and really everything in between. I currently manage our control and SCADA system work across the United States and Canada. And today I'll be moderating our discussion. As you have questions, please make sure you use the Q&A function that Diane talked about to submit your questions, and we'll try to address them as they come up. We want this time today to be as interactive and fun as possible, so please make sure you make use of that and shoot us your thoughts and your questions. And with that, I'd like to hand it off to Melissa to introduce herself.
Thanks, Dave, and thanks to all the folks joining us today. My name is Melissa Russo. I am also a business manager for SCS Engineers, Remote Monitoring Control Group, or RMC. I manage our drones in our GIS division. I've worked for SCS for 16 years. Starting in the OM&M admin group and transitioning to RMC in 2013. About 6 years ago, I got my FAA Part 107 pilot license, and that effort has resulted in leading the development of SCS's drone services with a fleet of drones and dozens of pilots nationwide now in Canada. Shout out to all of our amazing pilots. And a multitude of sensors, which I'm happy to dive into with all of you today.
Thanks, Mel. Phil, why don't you tell us a little bit about yourself?
Hello, everybody. I'm Phil Carrillo. I'm the Director of Remote Monitoring and Control for SCS. I've been working in the environmental industry since the mid-90s. My dad got me into this industry. He built a lot of the original flares. Shout out to my dad. Happy birthday, 83 years old. He taught me a lot about innovating, never quitting, and I owe a lot to him. And thank you for having me here.
All right. So let's jump in here. So Phil, why don't you talk with us a little bit about what landfill monitoring looks like in the future as a result of some of the current technologies that we're seeing out there right now?
Sure, no problem. So obviously, there's a couple big ones that you see in the news. Satellite monitoring just blowing up. We're seeing a lot of images from around the world of oil and gas sites, dairies, landfills of these leaks. And, you know, this all started a couple years ago with Carbon Mapper. They started flying sites and releasing it to the public. And, you know, currently, right now, you can buy a satellite image of anywhere, a 9 by 9 square miles for about $10K. I see, you know, a lot of nonprofit in the next year or two providing free images, and I see the frequency coming in hot. It's going to be, you know, weekly, daily. On the drone front, we're living it and breathing it. You know, looking back 6 years ago, we were manually flying drone. Now they're fully autonomous. There's the sensor manufacturers are making every sensor under the sky, and it's exciting. You know, from how quickly it's moving. You know. Yeah. So the next thing to keep your eye on is, you know, you guys have all seen the Boston Dynamics robot dog, and obviously it's pretty expensive. But you're seeing a lot of Chinese robot dogs that we're testing, and they're putting LiDAR on them, and it's moving quickly. So you can definitely see a lot of robot dogs and different robotics on the landfill in the near future. Obviously, we have automatic wellheads and sensors. You know, all the major manufacturers are moving to IoT, and, you know, all these systems are working together. We're working to tie satellites, drones, automated wellheads, the control systems, the RNG systems all together. And that technician is going to be sitting in the control room, you know, making decisions based upon all this input from all these various technologies.
Yeah, and I think that's you hit one of the things right there off the bat, Phil, that we want to make sure that we drive home today is that there's a plethora of new technologies that were coming out. We're going to talk about all sorts of them. We're going to start with drones and then make our way into automatic wellheads and compost systems and RNG systems and other stuff. But with all of these technologies, just as Phil was saying, we want to, regardless of how you're deploying them or who's deploying them for you, you want to be able to get everything together in one spot. That Phil and I talk about it as being this landfill as a factory concept that we'll talk more about here. But keep that rolling around in your mind that you ideally want to be able to have all your information in one spot so that you can really leverage all of that together to get the most bang for your buck out of whatever technology it is that you're looking at. So Phil, let's dig a little more into what you're talking about here. What do you see those new technologies meaning for landfills, for RNG systems, for compost systems, and the owners and operators of these facilities?
So the owners have to make the decision to invest, with a return on their money. Any new technology, they got to look at it, and they're evaluating the accuracy and what it's going to do for them. And they're doing the pro forma on automatic wellheads, or what a robot dog, the return, what that means to the technician. So they're evaluating all this, and we're working with landfill owners to make those decisions and advise them on all this technology.
Okay. So we're seeing some value, or they should be seeing value from whatever technology that they're implementing there.
Obviously, they're seeing efficiencies. We send a tech out to look for a leak. It's a needle in a haystack, where a drone can find a leak pretty quick now. It's one example. So it's reducing the O&M costs significantly.
Yeah, and I'm excited to have Mel talk more about what we're seeing from some of our drone monitoring stuff here in a bit. So we're getting a lot more data. It's being more efficient with the work that we're doing out there. So what do those same technologies mean for regulators?
So the regulators have to write the rules. Any sensor, calibration, quantification, how accurate, the methodology, how you take, the drone methane sensors, how does the wind direction, wind speed. So they're writing the methodology, and they're looking at all these technologies and writing the new rules. And we're helping to do tests and give them the feedback and the data so they can make smart decisions on the rulemaking process.
Yeah. So there's a lot of different technologies, a lot of things that are happening. What's your take on how distributed the applications of these new technologies are? Do you see them all in one spot? Is it all, and I'm just making something up here, is it all on closed sites? Is it on open sites, larger sites, small sites, privately held, publicly held? What's that distribution look like?
Typically, your technology is pushed on big open sites. They're getting a handle on the efficiencies of the system, so they're investing in a lot of this new tech, and it trickles down to closed sites. They obviously, the gain we learn on the bigger sites is trickled down to smaller landfills and smaller closed sites. So it's a win-win. And as far as the uptake, you're seeing. Personally, I see a lot of municipalities getting behind this now, and the privates they're looking at this, and we advise them on it. But I think it's a balance between the privates and municipalities that are investing in these systems.
Okay, so it's fairly balanced, and I think getting back to what you were saying before, would it be right to say that the value is there for really any of these types of sites that we were talking about, whether it's big or small or open or closed, but that it may look different from site to site to site as to what specific technology they choose to apply?
Obviously, yeah. I mean, you may have like an H2S issue and you're deploying H2S sensors, right? It kind of depends on the problems that each site's having, but in general, they can all benefit from satellites and drones and these various IoT devices.
Yeah, cool. All right, so as we're getting all this data, obviously it's coming in more frequently than data used to in the past. So how does this new generation of technology affect the quantity and frequency of monitoring that we're doing at these different facilities?
So currently, let's take surface emissions monitoring. It's required that we do it quarterly, right? And I guess, looking at, like, say, a drone, we're testing systems that can be deployed on a dock. So the pilot's not even there. The tech's actually more advanced than the regulations right now. So just imagine a drone, it docks and it deploys by itself. The pilot's actually in a control room. And these can be deployed at any time. They're autonomous. So you're looking at a landfill owner can look at his system anytime he wants autonomously. And that drone's coming back, charging, and then being deployed again. We'll take the example of satellites. So state of California is in the process of purchasing 2 satellites. With 2 satellites, they can see a site every 2 weeks. Granted, they have line of sight. So we're speeding up the monitoring frequencies. That's the big takeaway here. The same thing with the robot dogs. They can go out, come back and charge, and they're autonomously being deployed. So the frequencies on this is depending on a sensor. We're looking at, say a flow meter or a temperature sensor, that's in the seconds, minutes. And so we're just speeding up the time that we're monitoring these systems. And, the regulations obviously are going to have to catch up with that.
Right. And I think that if we kind of wrap this back into the big picture for what we're talking about here, that I think is one of the key points, that we're getting a lot more data from different points and from different sources, whether it's H2S or methane or oxygen or liquid levels or whatever it is. So we're getting different kinds of data and more of that, and then we're getting it much more frequently. And this, if done well, can allow all of these industries to be more proactive instead of reactive, right? That we're looking at everything together and we're using it to make smarter decisions. And I know we've got some great examples of that here in a bit from a methane emissions standpoint. But let's hop back to a point that you just made, Phil, about California purchasing 2 methane satellites. I know from my side of the country, you're in California, I'm in Pennsylvania on the East Coast. We see a lot of more early adoption of new technologies and different regulations from the western half of the country, and it seems to kind of percolate across the United States. How do you see this particular technology affecting California and then the rest of the country?
Well, obviously, California gets the jump when it comes to just being more progressive, and it'll eventually. So you have California purchasing 2 satellites, but I see other governments, purchasing satellites, and like I said before, there's a number of nonprofits that are coming out that are purchasing satellites. So it's like an equalizer here. You're just going to see a lot more imagery in the frequency, and I wouldn't be surprised if the EPA purchases a satellite here in the next coming years.
Okay. We just had one quick question come in that was relevant to what you were talking about there. They are asking if you could describe what the robot dog was that you were describing earlier. Can you give a little more detail on the Boston Dynamics dog?
Sure. So we've currently been testing a robot dog. It's a Chinese company called Unitree, and it has a LiDAR system on it. And it's actually, it's low cost. Depending on the one, they start out for you can get them as cheap as like 10 grand. Then you start adding sensors and the price just goes up. But the actual manufacturer that we've been testing is Unitree. I have a lot of colleagues in the industry testing other robot dogs, but that's the one I personally have tested.
Okay. And overall,
have no cleanup, no walking, no poop cleanup.
There you go. No allergies, right?
No dog keeping you up at night.
Yeah. So essentially, it's like a 4-legged robot, essentially, that can walk across whatever surface, whether it's here. I know I saw an example of one of this at a show last year, that it was literally walking across the show floor, and you can have different sensors on it, whether it's a camera or the LiDAR system or something else.
Let me add, a lot of our audience has been to a landfill. The terrain is rough. There's steep slopes, and we have, ditches and high grass, and we've tested a lot of different robotics on the landfill, and in my experience, the robot dog's the only one that can handle the terrain of most landfills.
Okay. All right. Well, hopefully that answered your question there, Hannah. All right. So, Phil, you were starting to talk about Carbon Mapper. Can you tell us a little bit more about what Carbon Mapper is and what effect they are having on the industry and have had on the industry?
Yeah, you know what? I don't want to steal Mel's thunder. We have different opinions on Carbon Mapper, but I'll let her give hers first.
All right.
Game changer, right? Speaking of nonprofit entity, Carbon Mapper is a nonprofit entity that started flying key emission sectors, and not just landfills or waste management sites, right? They target energy production facilities, agriculture, particularly livestock, coal mining, oil and gas. Started back in 2016, so about 7 years ago, and the purpose was to track strong methane emissions, obviously. But the kicker is that they make the data free and open to the public. I'm sure most of our audience is aware that data is in the form of a methane plume imagery with estimated emissions rates. This was and is a major disruption to the industry because facility owners and managers weren't aware that these monitoring events were happening, let alone providing accessibility and transparency via the internet to the public.
Yeah. Yeah. So let's talk a little bit about what impact that had on us here within the remote monitoring and controls group.
Yeah, well, our clients started to reach out to us knowing that we were developing our drone program, right, to fly the sites and locate leak sources, sources, right, by using a drone-based approach. We found that one of the current limitations of Carbon Mapper is the resolution at that high of an altitude, whereas our sensor is able to detect and localize leak sources. Subsequently, RMC gained valuable insights comparing our data sets to Carbon Mappers, and our clients have gone from, like you said, a reactive approach to a proactive approach by implementing reoccurring drone methane inspections. We're able to identify areas of concern before the site is flown by manned aircraft or captured by satellite, in most cases unknowingly, right, and mitigate those issues ahead of time and implement long-term operational enhancements.
Yeah. So it sounds like these are complementary technologies that we kind of have maybe different tiers that you can talk about, vertical tiers, right? That we've got satellites and then planes and then drones, and then we've got stuff below that too, like the traditional boots on the ground and some other stuff that you'll talk about here. And I think that that's also one of the key takeaways from this too, is that one of the really cool things about all the technologies that we're discussing today is that they can be complementary. You don't just have to do one, you could do all of them. And they can all fit together to provide a more holistic view of what's going on there at the facility. And Mel, why don't you talk a little bit more about the efficiencies that we saw as we started to do more drone flights?
Yeah, so I mean, let's take a step back and look at where we started. Initially, we were only able to inspect 200 acres in a day, and now we can cover up to 600 acres in a day. That's a huge improvement, triple the coverage in the same amount of time, right? This is a direct result of advancing drone technology, particularly extended battery runtime, which now allows for 40 to 45 minutes of flight time. We also have hot swap capability, which means we don't have to turn the unit off for a battery swap. This limits the time on the ground and maximizes our time in the air for monitoring. Another improvement has been the implementation of real-time terrain following by using a laser or radar altimeter to keep the drone at the same height above ground level throughout the inspection. It used to be that we'd have to fly the site a day before for topography, process, and upload the digital terrain model for following. So real-time terrain following eliminates an entire day of labor and provides more accurate flight height, since every day on a landfill is unique and different from the next, right? Especially in active zones. All of our drones also have obstacle avoidance sensors and FPV, or first person view camera, which are safety features that help us navigate obstacles on landfills, which are, just constant with equipment and traffic and cranes, conveyor belts, tippers, drill rigs. It's constantly in motion.
Yeah. So getting back to that kind of tiered approach, how does what you've just described with our drone approach compare to traditional SEM, and what are some of the challenges with traditional SEM?
Yeah, well, the obvious, right, is how physically demanding traditional SEM inspections are. Considering an average landfill size requiring SEM is 100 acres, a technician will walk a minimum of 15 miles in varying environmental and weather conditions. You got snow, rain, ice, hot, cold temperatures, over varying terrain, steep slopes, dense vegetation. This all increases the risk of slip, trip, and fall hazards. And there's also the threat of wildlife, right? We've seen snakes and moose and bears. There's dangerous vectors, ticks, spiders, mosquitoes, and as well as the increased exposure to landfill gas. Then there's the limitation of the areas that are accessible by foot, right? Because drones can be operated and adjusted remotely. They cut back on the need to have workers in dangerous conditions to collect data. Instead, the drones can be flown over challenging terrains, around obstacles, and we can continue our work from safe ground. Another difference is that drones can perform repeatable inspections, which leads to consistent and reliable data. For example, have you ever tried walking a straight line on a landfill? I have, and it's I would guess similar to like getting pulled over for like a sobriety check. It's nearly impossible. Not that I've ever experienced that, but you know what I mean. It's just a natural human limitation on an uneven terrain. Unfortunately, this makes for inconsistent data sets, whereas a drone flies a straight path at the same speed, at the same elevation, above ground throughout the inspection, which provides us with redundant data sets, right? And that gives us multiple sources of the same information, which validates the results obtained from our comparison.
Yeah, and I think you hit on two really important things that I want to make sure that we highlight here. The first one is that with all the technologies that we're talking about, one of the things that we're really trying to do and are achieving with them is reducing the health and safety risk. And that was a perfect example that you just gave there, Mel, that we have a person in one spot and they're not having to move through the difficult terrain and exposing themselves to animals and all the other stuff, slip, trips, and falls and whatnot. Yep. And then the other aspect that you hit on was that these technologies are allowing us to get data in places where we haven't had it before, whether it's a drone flying over the operating face or over some really steep area or other inaccessible spot. Or you can think about it from like a traditional landfill SCADA or RMC system that we're able to put sensors now like inside the landfill, that we can literally get the temperature 300 feet below grade and know what it is every single hour of every single day. I mean, it's a game changer. So it's another really cool aspect of all the stuff we're talking about. And why don't we hit pause here on the questions? We've got 3 more that just came in that I think we can tackle. One of them from Doug, we are going to tackle here, I think in a sec, on the typical height that drones fly over the ground. Or maybe Mel, you want to jump in with that now?
Yeah, we fly at between 15 and 20 meters above ground level. Okay.
Next question was on what method of detection we're using for the drones. We will be tackling that one here just in a minute, so we'll come back to that one. Yeah. And the next one was drones and robot dogs and other types of more land-based equipment fill a similar niche. And Bob was asking what the pros and cons of each one are. And Diane, maybe you can pull up that graphic again while Phil and Mel give us their thoughts.
So obviously, I think it comes back to the regulations. We'll say the proposed regulations in Canada, right? They have monitoring with drones, but you have to do a ground verification. So the ground verification, I think, is going to be autonomous with a robot dog. So you kind of need a little bit more resolution. That's why they go hand in hand. And you'll see robot dogs with arms on them. So they do repairs. Like say you have a broken hose, it could easily repair a broken hose on a wellhead or take samples. There's some cases we can't send a technician in. It's too hazardous, but it's perfect for a robot dog to go pull a sample or to do what it needs to do. So you kind of balance what you're trying to accomplish. You know, drones can pretty much, I think, cover a lot of it, but sometimes you need to send in a ground crew.
Okay. With one related question, and this may come up in some of the later points that we'll make, are the technologies that we're talking about here for surface emissions monitoring via drones EPA approved? And maybe we want to tackle that in one of the next questions.
Either way, we'll tackle it now or later.
Why don't we, actually, I think it's the next question. So what are the, we've talked about a bunch of different technologies here, and I know that we've looked at a bunch of different monitoring technologies over the years. Can you guys describe what those technologies are and our thoughts on those?
Yeah, so there's 3 main technologies for drone-based monitoring that we've tested. There's optical gas imaging, or OGI. There's infrared sensor or IR, and there's tunable diode laser, which, to answer someone's question, is what we've aligned ourselves with. But this is like he loves to geek out on this stuff, so I'll pass it to him. He can answer all of the details on each of those sensors.
Sure, no problem. So let's start off with OGI. So it's a form of thermal, and we've tested a lot of different manufacturers. And at the end of the day, it works well in oil and gas because oil and gas has high concentrations of methane and high flow. We've had limited success with OGI on the landfills because it's the opposite. It's low concentrations of methane and low flow. That's not to say, the industry is moving quick and I see the resolution coming up. But for right now, I don't think it's in its current state, it's going to work. I see in the future pairing OGI with the TDL, so you get an image with a concentration. And then, let's talk about IR. So IR, someone asked about, there is a method 21, there's an exemption to use IR. And I guess the issue I have with IR is you have to fly so close to the ground, and it's a heavy instrument, but it is approved.
Okay. So the question that we were asked then about the emission surveys, out of all those technologies that we talked about, the only one that's currently EPA approved is the infrared sensor, and there's specific ways that needs to be used for it to be approved.
Yep.
That's correct.
Okay. All right. So Phil or Mel, do you want to tell us a little bit more about why we aligned with the TDL technology?
Sure. So we first started testing TDLs that were handheld. They're built for the technician on the ground, and we hooked up the TDL to the drone. And we soon found out that the accuracy was there, but we had to fly a certain distance off the ground. So we started testing terrain following using altimeters. And we went through a bunch of different altimeters till we found the one that works. And that allows us, as Mel said, to fly 20 meters off the ground. And in this last 5 years, we're completely autonomous, and that's huge. TDLs are lightweight. We can use smaller drones too. And let's talk. So the TDL, it's a laser, and it's looking down, and we're getting real-time information. So the technician sometimes can stop a flight and stop the autonomous flight and move in to see where the actual point is, or sometimes radio to a ground technician to go investigate further, and then they keep on with the autonomous flight. At the end of the day, they're gathering all this data, and we automatically upload to RMC Pro to create the maps, deliverables for the clients. So when it's all said and done, TDL, it's cost effective. It's for the speed, we're doing 600 acres in a day, and the accuracy for the cost, it's where it's at. Yeah,
and I think that from my perspective, it fits well with that kind of tiered approach that we were talking about, that since you're getting the live data, you're able to send the boots out on the ground to find, okay, we know it's in this section of piping. Is it the flange? Is it the valve? Is it the, I don't know, whatever else might be there on that section of pipe? And then they can fix it, right, as we're doing the rest of the flight.
So a lot of times Mel's crew is sending them a lat long with an image of what triggered the alarm. They get a real-time alarm on their controller. And, I just want to add in, I give the drone pilots credit. Landfills, big open landfills, you got tippers that raise up 60, 70 feet up in the air. You have drill rigs, power lines, and they have to, from a health and safety perspective, they're putting no-fly zones. And the TDL, it's a safe altitude to be flying. And, with all the things that are happening on the landfill, I don't see any other technology in this current time that could pull it off,
So that's a nice segue there to a question that just came in. Or do we know offhand how low the ground vegetation must be to use the approved IR technology with drones?
So typically the landfill owners will clear before. We've tested it, in grass 3 to 6 feet with success. Now, as far as we typically don't see trees and higher vegetation on landfills. They tend to be bare. And we don't fly too many closed sites. Our bread and butter is flying big open sites on a quarterly basis. So we don't get into, big vegetation just because it's uncommon on the big open landfills.
Right. But specifically with the IR technology, there's a tube that's attached to the drone, correct? That is.
Oh, I'm sorry. Yeah, so we have very limited experience. We've tested IR, and we just haven't aligned on that technology. So I couldn't really tell you. I would think logically that it could get caught in high vegetation, but I'm unsure. Mel, do you have any thoughts on that?
Well, like Phil said, we've observed, and I don't want to speak too much on something that I don't have too much experience with, especially if my experience has been just a spectator, right? But I have seen it kick up behind, but honestly, I don't want to speak to something that I don't have the expertise in.
Okay. All right. Fair enough. So kind of on a similar vein of things that can affect our monitoring, can you describe how weather plays a role in our flight planning and ability to execute on surface emissions monitoring?
Yeah, so high winds and rain can be obviously problematic for methane emissions inspections, particularly drone-based inspections, for several reasons. There's dispersion of methane, there's the dilution effect, there's the cover effect, equipment functionality, safety concerns, right? In our experience, to conduct accurate methane inspections, it is often preferable to have calm weather conditions with low wind and minimal to no rain. Bottom line is bad weather, bad idea. It can complicate efforts, minimize inspection time, and make it challenging to detect and measure accurately. That said, but we also know that atmospheric pressure influences methane emissions at landfills. If there's a low pressure system or a storm, emissions go up, right? Which can be beneficial in finding vulnerable points at a site. Conversely, when atmospheric pressure increases, the gas contracts, which might temporarily reduce emissions. So something to consider depending on the situation at the site.
We just had another question come in. It asked what system we're using for surface emissions monitoring, and is it EPA approved? Is it IR? And how does the technology compare to another vendor like Sniffer? And I think we've hit on a lot of that, but Phil or Mel, do you want to add anything else?
So for regulatory, we're still our own M division still using, IR or PIDs and FIDs to comply with regulatory. I'd say 100% of our business is non-regulatory. We're doing, after a satellite image is given to the client, we're going in and finding the leak. I know Mel has weekly, quarterly contracts. They're not for regulatory, to be clear.
Right. And it's not that the technology couldn't do it. It's just that the regulations have not approved the use of the technology for that.
That's correct. And, speaking of that, Canada is adopting their proposed rules for drone. CARB has, they're working on proposed rules for IR and TDL. And I know the EPA is not far behind, so it's coming the next couple of years for sure.
Okay. All right. So with all of these technologies that we've been talking about, there's a lot of data that comes from that. Can you describe what we're doing with the data and what our process is there?
Yeah, so once the inspection is complete, the pilot uploads the data into our Esri enterprise system for data processing. So this includes filtering by data quality and data point collection altitude. The sensor provides a data quality indicator for each reading that we run through our software to extract readings that do not provide good intensity. The height at which the value was captured is also essential to consider during our data processing to avoid capturing readings that are collected either too close to the ground and could be compromised or diluted by prop wash, or readings that were captured at too high of an altitude that would fall outside of the sensor's measuring distance. These data quality control procedures give us the ability to visualize validated data from each monitoring event. Like I said, let's circle back to, where we started off and responding to call outs due to flyovers or satellite captures of methane. A plume, such as this that you're seeing on the screen, may look familiar to a lot of the people on the call, right? It's an example of, and I'm going to kind of walk you through an example of flying a site to find the sources of those plumes. So first, this comes up, right? You get an email or you get a call or something in your inbox that gives you this plume imagery. Not a lot of information here. It just looks like a pretty good sized blob, right? So we get called out, we launch our drone. First, we capture and upload updated aerial imagery just to give us a really good reference point of what's going on at the site. There we go. Sorry, there's a little bit of a lag on Zoom. So once we are updated, we're able to upload the ortho, we then launch our TDL system. Well, let's see another event here. Huh, does not like that. Okay. Well, if my Wi-Fi were to cooperate, you'd be able to see the drone flight, the drone path. You'd be able to see all of the data points that are collected while we're out there. Each data point gives a reading, a date and timestamp, a lat and long. We are also able to incorporate the weather data, which is also available here on our dashboard. And kind of circling back to what Dave said earlier, just providing one platform with all of the information, all of the landfill systems in one place. Getting back to this, MEM stands for Methane Emissions Monitoring tab. So while that populates for us, we'll be able to see some additional layers going on here. There we go, a bit of a lag. So now you're able to see the drone flight, the path, the serpentine path across the entire site. And so once we launch and we're able to fly these sites, you do see a correlation between some hotter spots from the drone path. And here you'll see some of the information for each of these data points, right? Some of these exceedances that are showing up, we're able to see that there is a correlation. So the next step would be to see where it's correlating exactly. So what we would do, or our client would open the localization tool down here at the bottom of their screen. And they're able to filter, let's say we don't want to look at all of these points, right? We want to look at all of the higher values or the higher ratings. So they would go in here, they would filter by, let's say, 500 to 5,000, implement that filter the raw values by that amount. They can pull this out, pull it up on their phone, and they're able to send the ground crew. They know exactly where to go, right? They find the exceedance. They're spending more time on repairing than finding the problem. And as you can see here, right, from the plume versus these two hits that are then quantified by the ground verification, right? That you're not just seeing one leak source, you're seeing a couple leak sources. So with this tool, our clients can then filter by higher values, pull it up on their phone, right? Focus their efforts and identify those root causes. And not only that, but by adding layers over time, right? So they've gone from reactive to now proactive. We're flying on a quarterly basis. At some sites, depending on what is going on at the site, we might be flying on a monthly or bi-weekly basis. So it really tells the story and the health of the site, especially when you look at all the systems at the landfill from one platform like RMC Pro.
Melissa, can I ask a question?
Sure.
So if I'm a supervisor and I'm looking at that map, could I have my technicians also looking at the map at the same time? So I'm literally, say I'm physically somewhere else on the landfill, and I can
absolutely.
tell
And I
them,
think
go to
Phil
this.
touched on this earlier, but we're able to see real-time information as it's happening. So as the drone is in the air, we're able to see that on the remote controller. We're noting where those exceedances are, and we're deploying ground crew to, go here, repair that, let's move on. Let's get this done today.
Right. And so because it's real time, when the repair is made, you can see the immediate capture of more methane. For example, if you're, say, looking at the map you just had up on the screen.
That's right.
Pretty cool.
Yeah, it's a great tie-in back to this overall concept of what we're talking about here is how all of these things can really affect all the different aspects of the industry that we're involved with here, whether it's landfills or RNG or compost facilities, that this technology can help all aspects of that. A lot of what we were just looking at there was laser-based technology, and I think we've got one more that we wanted to talk about. Can we touch on that briefly, and then hop over to some more on the RNG side of things?
Yeah. So we've recently added LiDAR to our suite of services. LiDAR stands for light detection and ranging. And so how LiDAR works is by using light waves that bounce off objects and return to the LiDAR sensor. The sensor uses the time it takes for each pulse to return to calculate distance. Each of these pulse laser measurements or returns can be processed into 3D visualization known as a point cloud. So I'm going to share another screen with you guys. So on drones, it offers an unprecedented level of accuracy and detailing in 3D mapping, which makes it an ideal application for high precision anything, right? As-built drawings, airspace, stockpile, settlement calculations, pre and post construction, engineering and pipeline. It also has the ability to penetrate some vegetation, which like Phil said, not necessarily a problem in the Southwest, but more on the East Coast, right? You guys have a lot more vegetation than we do. So it can penetrate those ground covers, grass, to provide accurate DTM and DEM for specific landscapes. And this is kind of an example of, you can see where the drone path was up in the air, right? And we're also able to show, this is shown elevation, but we can also at the same time, which saves a lot of time, a lot of cost for the client, include RGB at the same time as capturing the LiDAR. So just a really good tool and quick and efficient, very easy workflow. It also has the capability of capturing not only from the sky, but we can pull off the unit and capture on the ground for detailed 3D images in areas that have like very little room. So indoor modeling, right? It's perfect solution for building information modeling or BIM, plan, design, construct buildings. So really good tool that we've added to our suite.
And I think you hit on one of the questions that just came in, that the difference, or when you would look at using LiDAR over traditional photogrammetry, is when you need more accuracy, and then also possibly when you need to like look inside of a building. Is that accurate, or are there any other times that we'd look at one versus the other?
Yeah, I mean, going inside the building is really key for this solution, because we're able to not only get it from the aerial, and we can incorporate both captures from the air and also on the ground. So you're able to navigate from outside a building all the way to inside the building.
Good. And offhand, do you happen to know how large that file was that we were looking at there? Is it several gigabytes? Is it a terabyte?
Well, this is a web-based application, which makes it ideal, and we can also incorporate it into the RMC Pro platform. So you're not necessarily having to deal with large-scale files. But in this particular case, I believe it was close to about a 20 gig file once you extract it.
All right. So we'll hit one more question here and then we'll continue on. So the question was on repairs. So let's assume, Mel, you have that example of showing the emissions coming from issues that were identified at the facility. Let's assume it was a can of Flex that was knocked off or something. What is our thoughts on an SOP for when you should recheck that the Canaflex is sealed correctly or that we've refilled the trap or whatever it is? Is that an immediate thing, or do you just move on to next quarter and assume that it's been fixed?
It really depends on the client and the site operations, the way that they're managing the site. Our clients who are being proactive with the technology, we can be there on a quarterly basis, but we're also able to go and identify those issues right on the spot with our ground crew, which is the beauty of having, SES engineers, right? We're all over the place. Phil, were you raising your hand?
Yeah, so certain issues can't be fixed by the technician. It's kicked to the engineering team. They have to add wells or redesign a new sump. It might be an engineering solution, but they're using this information to make engineering decisions.
Yeah.
So it's probably best to try to fix it and then double check with some sort of handheld device as quickly as you can. But to Phil's point, some of them are larger issues.
Yeah, I think that's where it really is such an amazing tool when we are doing reoccurring flights, because the first flight or one flight is really just a base layer. Once you start adding historical data and seeing all of those comparisons and where are there reoccurring areas or issues or areas of concern, right? That's where you're really able to implement long-term results.
Okay. So continuing on with some of the other aspects of what we wanted to talk about here with the RNG applications. We've been talking a lot about wellheads, and another technology that's gaining a lot of traction here in the landfill and RNG industry is remotely monitored and controlled wellheads. Phil, can you talk with us more about how these products worked?
Sure. So, remote wellheads have been around actually, but you're seeing a lot of efficiencies in batteries. Lithium battery technologies, we can power all these things in a tiny footprint. So you have a tiny solar panel, small lithium battery, and you have an analyzer, pressure sensors, temperature sensors, and we're not only just looking at that wellhead, we're looking down into the landfill. It could be a thermocouple, liquid levels. Then going outside that wellhead, we're now seeing air monitoring. So it's like your wellheads are the heartbeat of the landfill. And leading into RNG, I can't see how RNG facilities to maximize efficiencies, how they can't do it without automated wellheads. And with the ton of sensors that are turning to IoT, it's become easier to implement.
Right. So it seems like the uptick is being driven by the benefits that come from automatic wellheads and increased monitoring and better understanding of what's going on at the facility. And getting back to the point that we were making before, it seems like we've hit that point that we've been dreaming of here, Phil, for the last 10 years, that the landfill is essentially a factory. Can you tell us more about what that means and what the implications are there?
Sure. So let's just take the example, you got an automatic wellhead. Well, now these systems are talking to each other. So the wellhead's talking to a probe, talking to the RNG facility, the RNG facilities looking at the weather stations. All these systems are now talking together. We're starting to use machine learning and AI to make decisions. So nothing's an island anymore. All these systems are working together. Okay.
And we're seeing similar adoption of new technologies in the compost industry. And with the push to zero waste composting, I want to spend a little bit of time talking about some of the new technologies for compost monitoring. It's a big part of what I've been doing here for the last several years, and several companies, including SCS, are providing automatic temperature monitoring solutions. And the way that we approach this is that it's similar to how we approach our RMC systems for landfills, like Phil was talking about, that we want to provide that one single pane of glass, one dashboard, the factory, that we can use to operate and maintain the facility. So in the context of a compost facility, this means that through this dashboard, this single pane of glass, you can virtually create your new compost piles. You can automatically monitor them. You can receive automatic reports on the piles and how your operations are affecting them. You can receive alarms when there's a problem with the equipment or with the pile or the temperatures or whatever data we're gathering. And then you can also review key performance indicators, or KPIs as they're known, on how the system is operating. And then as you're getting all this information, again, getting back to what we were talking about, we can be proactive. If we identify that our temperature's out of whack, we can change how our blowers are operating for that particular pile. So we can adjust the set point on the blower or on the valve or the pump or the tank, or turn things on, turn things off. So regardless of what system you choose or who you're working with, you want to look for something that helps you to be proactive, meet your regulatory requirements. So a lot of temperature related stuff there for compost. Manage and mitigate odors. That's a big issue with compost facilities and landfills, and something that
Dave,
lowers
let me ask you something real quick. What
Yeah.
On the temperatures for composting, what technologies are you implementing?
Yeah. So we're using a lot of battery powered equipment. It's a nice mix for compost facilities, and we're doing this. We'll talk more about it here, but we're doing this also in the landfill side of things as well. That by having things battery powered, you are able to not have to worry about the wires that we're connecting things. So we're pairing that battery powered unit with either a local radio system or an IoT device. So we're essentially either keeping the data there locally and we can still send it up to the cloud as needed, or we're going straight out to the cloud and streaming it up there automatically.
Nice.
Yeah. So I was just talking a little bit about about IoT and Internet of Things for the composting industry. Phil, can you tell us more about how the Internet of Things or IoT is affecting the overall waste industry?
Sure. So, well, first of all your sensor manufacturers are moving towards an IoT. Let's take a pressure sensor. So, before they would just sell a pressure sensor. Now they're pairing it with a battery and they're giving you the outputs, the digital outputs, and everything you need to get it up to the cloud. And you're seeing some manufacturers include modems and communication devices with their PLCs and various sensors. And I know, Dave, your team's incorporating a lot of these devices that have the cell modem and everything's all in one. So it's a huge benefit and help to us for deploying it and bringing the cost down. But I see that IoT in general, we're getting low cost sensors all over the landfill, all over the LFG system, and it's we're having to manage all this data and get this data to talk to each other. So it's our industry is benefiting from the big IoT trend.
Right. And that kind of reps back into what we were talking about for composting and RNG systems, is that by using these IoT devices, we're able to get data where we couldn't before. Getting back to what we were talking about with Mel too, that we could stick an IoT device or fly a drone over some completely previously inaccessible area and get key information that we didn't have access before, that can help us better operate that RNG facility, make more money, be more efficient in our gas collection, and reduce our emissions. So it's a real game-changing technology as a whole. So to kind of put a bow on what we've been talking about here, to wrap stuff up, we've talked about a lot of different technologies, and how do both of you think all of these technologies are affecting people, the environment, and the bottom lines of the facilities that we're working with?
So I'll first start out. We're already the technician, his job duties are changing. They're already becoming drone pilots. They're learning to work on IoT devices and robotics. So we're training a whole new generation of workforce to embrace this technology. As far as the landfill owners and O&M, we're reducing O&M costs because we're finding problems, quicker, easier. And this is improving the efficiencies for the RNG systems. But, big picture, we're improving the quality of life for everybody working at that landfill. That we're increasing health and safety. We're not exposing technicians. When you can send a robot dog in, we're not exposing them to bears and moose and alligators. We're reducing that health and safety risk. So, it's interesting to see how quickly this technology is moving, and I'm excited personally. I mean, just in the past 3 years, it's blown my mind how quickly we're moving and how the landfill's coming of age.
Yeah, and kind of adding to that, we're helping our clients reach their sustainability goals, right? That's changing. It's getting aggressive, and if you are wanting to meet those goals, you got to take aggressive measures and figure this out now.
a lot of those are quantitative measurements, and Mel, you touched on a kind of a qualitative thing we're all shooting for. But at the same time, I would imagine if you're, using this technology in a landfill and you've in the past had a lot of nuisance reports, the fact that you're capturing more methane and you're reacting to it faster, you must see a decrease in nuisance complaints and things like that.
Absolutely.
Yeah,
Good
nobody
point.
wants to be on the front page of the local paper, so.
No.
While she's doing that, we got a couple quick things I'll go through from the Q&A perspective. One was a question on the heat map, asking whether the heat map accounted for wind speed and wind direction. And at least from the satellite imagery, it would account for that. And that's what you were seeing in that image, that the hot spot was on the left and basically the plume was going to the right. And then Phil, we've got a shout out that you are all the work that you and Mel are doing here is going to negatively impact the traditional landfill fitness program. So we got to take that into account as we're thinking about the health and safety risks. So maybe we'll have to get some gym memberships for the landfill workers, since they won't be walking quite as much.
Layer comparison, here you're seeing data point, heat map, ground, some exceedances, and a carb flyover. And then another example of, flight path, heat map, high resolution imagery as a reference point, and historical data on the right. And then I didn't get into this, but we also have, I showed you guys the 2D maps. We also are able to implement 3D maps in addition to drone methane data. So just kind of giving you a different way to visualize your site in comparison to the terrain as well. And then just some examples of other drone sensors that we're using. Here's an example using the LiDAR, the data point cloud from the LiDAR scan, and thermal. And then Dave spoke on RNG, composting, and how it's visualized on our platform.
Yeah.
Very nice. Thank you.
Sure.
Thanks, panelists. You never cease to amaze me. I can't wait to see what you're going to have for us in 3 months.
You're the first one we call, Diane.
Thank you. Goodbye, everyone.
Thank
Bye-bye.
you.
Bye, everyone. Thank you.
Great.